All right, so guys, good afternoon. Probably by the time you come back to this video here or view this video, it'll possibly be evening or night, and that's fine. Uh, I just wanted to go over some things that you guys do need to know again for the basic math test for NCCER core. Okay, the second module is basic math, and I'm going to kind of go through some things that we've already covered because we have had one that's missed a couple of classes. Just want to make sure that we stay on one accord. So we're going to make sure that we cover everything that that person could have possibly missed. Okay, so you guys just bear with me. For the ones that know the information, good. Okay, great. Just kind of hang on here, and I'll be going over some new information. All right, but of course it's always good to go over some things so that we can refresh our memory. All right, so the first thing that we're going to cover will be fractions. All right, so remember we talked about improper fractions and we talked about mixed fractions. We talked about proper fractions and we talked about reducing fractions. All right, so again, I just want to kind of go over some things. So say I have a number here and I have one here. All right, this is just an example. The number up top is my numerator. Okay, the number below here, in this case, it's a y. Okay, this is my denominator. Okay, and it's gonna always be like this when dealing with fractions. Okay, all right, so what do I mean when I say let's take the reciprocal of this fraction here? Well, the only thing that I'm saying, and let me just write this out, reciprocal. Okay, all I'm saying is I'm going to flip this fraction. So instead of it being x over y, it would be y over x. Okay, now that's very, very vital information when it comes down to when it comes down to dividing fractions. Okay, and we're going to go over that briefly. Okay, all right, I hope you guys can see that, and I apologize, I don't have anything I don't have it set up to where I can have everybody on the screen and get you guys' questions, but it's okay, we're gonna make it work. All right, this is not anything that's new to us. Okay, all of this is not totally new. All right, so first thing first, how can we turn a decimal into a fraction? All right, how can we do this? If we have a word problem and it says convert this decimal into a fraction. All right, I'm going to give you an example. Say we have zero point 0.6, for example. How do we turn this into a fraction? All right, so we understand that there's a zero here. Okay, it's here. It's not going to always be zero, but it's understood that there's a zero there. Okay, all right, so remember I gave you guys in class, do you guys remember this? Let's see here. So hopefully you guys will remember. Thousandths, okay? Hundredths, and look how it's spelled. THS. THS. Alright. Tenths. THS again. And then we have the ones. And then we have the tens, hundreds, thousands. Look at how it's spelled. I'm not adding a THS to anything. Okay, and then it goes into the 10,000ths. Okay, and then so on, so far. All right. So our number here to turn into a decimal is 0.6. Okay, and if you remember on that chart, there is a decimal point right here. Okay. Also on that chart, there's a comma right here. And there's another comma as you go up past 100,000, because that's what goes here, 100,000. And then it gets to 1 million. All right. So there's also another comma right here. Okay. Now we're dealing with a decimal that we have right here. Okay. This is telling us that this is the 10th place. Okay. Let's look and see. Actually, the point is here. Okay. And right next to this point will be the 6. All right. See? And that tells us that it's in this 10th place. This means that we can divide 6 over 10. Okay? So this is the same thing as this. Okay? So we just converted this into a fraction. All right? And we can go on and reduce this. If we were to reduce it, 2 goes into 6 3 times, 2 goes into 10 5 times. So it reduces to 3/5. However, when you take your test, okay, and you may get a number like this. Let me do a different example. 42.423. All right. Okay. In this case, if we come down here, all right, this will be 4 2 3. This gives us the number that it's going to be over, right? The thousandths. So we will write 1,000. And when we calculate it in our calculator, we will type it exactly like we see it. 0.423 divided by 1,000. All right. All right, and whatever answer it gives you, which would be 123.423.0. Okay, that will be the answer for it. So you just converted 0.423 into a decimal. All right, again, 423.0 would be your final answer. All right, so we know how to turn decimals into fractions. All right, and we know how we got the 10. All right, again, for the ones that may have missed it, we take a look at this decimal here. We have a decimal here. This is the only decimal on this chart. All right, so we put that decimal, that 6 behind that decimal. Okay, and this number here tells us what the denominator will be, which is 10. All right, so when you type it in your calculator, you will type it as is, 6 divided by 10, and it's going to give you 0.6. All right. So again, this is a place value. Okay, you guys need to know it. Okay, thousandths on the end, hundredths, THS, tenths, and then ones, tens, hundreds, thousands, 10,000s, 100,000s, million. Okay, 10 million, 100 million, trillion. All right, and it just keeps going and going. All right, so I'm gonna get rid of this. Okay, all right, I'm gonna get rid of all of this. And again, I do apologize. I just want to make sure that we cover what we need to cover in order for everybody to get through the test. Okay. All right. Also, all right. So let's go ahead and cover adding fractions. Okay. fractions. I don't know where my head is. All right. So we have fractions with uh unlike denominators, and we have fractions with like denominators. Okay. What this means is we have fractions like 4 over 8 plus 2 over 6. Okay, that's one. Remember, the denominators are the numbers on the bottom. Okay, so these are the denominators. They are unlike. All right, then we have some that are like. Okay, 4 over 8 plus 4 over 8. All right. All right, so in this case, we would have to find the least common multiple. Okay, so in this case, we would take the smallest denominator. This is the long way. I have to teach you guys both ways. Okay, once you get used to know, or if you already know it, that's cool. But the ones that don't, I must show them. So you guys bear with me that know. All right, so we would have to find a like denominator. Now, in most cases, we will be able to multiply the two bottom numbers and it'll give us a like denominator. However, that does not always work. Okay, so we're going to go with what we have. We're going to go with what works. So in this case, I would take the smallest denominator. I would say 6 times 1 is 6. 6 times 2 is 12. And what I'm looking for is a number that 8 can go into as well. Okay, so 6 times 3 is 18. 6 times 4 is 24. Okay, I have a number. See, this is why I say multiplying these numbers don't always work, the two bottom numbers. Okay, because if we were to multiply, that would give us 48. Okay, and 48 is unnecessary. All right, we don't even have to go that far to find a number that 8 can go into. And 8 does go into 24, and so does 6. Now, how many times does 8 go into 24? It goes 3 times, because 3 times 8 is 24. So we're going to write a 3 here. Okay. No. I'm sorry, y'all. We're going to put our 24 down here. I don't know where my mind is again, because 24 can go into, 8 can go into 24, and 6 can go into 24, okay? What do I mean by this? 8 divided by what gives me 24? 8 divided by 3, okay? All right, 6 divided by what gives me 24? 6 divided by 4 gives me 24. All right, so 3 times 4 is 12. All right, 4 times 2 is 8. Now, since I have like denominators, I am ready to solve. Okay, so 12 plus 8 is 20. So it's going to give me an answer, 20 over 24. All right. Now I have both odd numbers on the top and on the bottom. Now when there's an odd number on the top, this means that you have to do more reducing. Okay. 20 can be reduced. So can 24. Okay. All right. So to reduce this, we would say it's an odd number. All right. So to reduce it, I'm going to pick 2 to go into both numbers. So 2 divided by 20 is 10, and 2 divided by 24 is 12. Now I still have an even number on the top, so that means that more reducing has to be done. Okay, I can't stop reducing unless I get an odd number on the top. Okay, so I'm going to reduce it again by 2, because 2 can be divided into 10 and 2 can be divided into 12. Okay, and 2 can be divided into 10, that gives us 5, and 2 divided by 12, that gives us 6. Now I have an odd number. Odd number. Now I am complete. Okay. Now in this case, we are starting out with like denominators, so we don't have to get a like denominator for this problem. We don't have to find one. Okay, it's already here. So what we would do is simply add. Okay, we would add. Pay attention to your signs, guys. All right, it's very important. All right, so when I add 4 plus 4, I get 8. And then the denominator stays the same because they are like. All right, 8 over 8 reduces to 1. Okay. All right. This is something that you guys must practice, okay? I want to do another one with a like with an unlike denominator. Make sure you guys get the gist of it, all right? So I'm going to take a small number, 2 over 3 plus 4 over 15. All right. Now, out of this, we see here what our denominators are, our bottom numbers. Okay. So we immediately, I take the smallest out of the two numbers, okay? I take the smallest out of the two. You can take 15 if you want. That's fine. All right, but you have to do the same thing. 15 times 1, 15 times 2, okay? So I'm going to take 3, and I'm going to do 3 times 1 is 3. 3 times 2 is 6. And I'm trying to find my LCM, okay? A number that 15 can go into and also 3. All right, so 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is, Lord and behold, is 15. This is what I need. Okay, I need 15 under both of these lines. Okay, and if I do my 15s, 15 times 1 is 15. Lord and behold, that's exactly what I need too. All right, so 15 goes here and it goes here. All right, so now that I have my like denominators, I'm ready to solve. All right, so 15 divided by 15 is 1. Okay, 3 divided by 15 is 5. All right, now that I have my division out the way, okay, let me say that again. 15 divided by, okay, 15 divided by 15 is 1. Okay, 1 times 4 is 4. All right, 15 divided by 3 is 5. 5 times 2 is 10. Okay, so now I'm ready to solve. Remember, I'm adding. So 10 plus 4 is 14. The denominator stays the same, 15, because we are adding. All right, we are adding. All right. All right, so that's some examples of addition, okay? This, you have to do the same thing with subtraction. Same deal, okay? Same deal. Only difference is in the end, when you're ready to solve, ultimately ready to solve, you have to remember to subtract. All right, so let's do subtraction. Like and unlike. And what is this referencing? The numbers on the bottom, because those are our denominators, okay? So a subtraction problem all right, this is a subtraction problem. The only thing you have to do, since your denominators are already the same, keep them the same, okay, and solve. 4 minus 1 is 3. Keep them the same, bring your 8 down. All right, with unlike denominators, 4, 8 minus 2, 24. All right, now I like denominator, so I'm going to take the smallest denominator I have here, which is 8, and I'm going to say 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24. Oh, got what I need, 24, and it goes in there 3 times. All right, now I'm going to go to 24. 24 times 1 is 24. Oh, got what I need. All right, I got what I need. 24 goes into itself one time. All right, so I'm going to put 24 here and 24 here because we already see that 24 goes into 24 one time. So we write 1 here, and then 1 times 2 is 2. 24 goes into 8 3 times. 3 times 4 is 12. And remember, I'm ready to solve and I'm subtracting. Okay, I always look back at that sign. All right, so it's going to be 10 over 24. This number is uneven. Okay, so that we have more reducing to do. All right, 2 can go into 10 5 times. 2 can also go into 24 12 times. Now I have an odd number and I'm done. All right, I'm done. All right, so remember, if they have like common denominators, keep it the same. Well, I mean, subtract it, all right? Leave your denominator the same. If they have different denominators, find your like least common multiple, like I did. I take the smallest number as far as the denominators go, which is 8, and I start to work my way up to that big number, okay? And remember, this is always divided, and then after that's divided, then the answer is multiplied by what's on top here. Again, this is always divided, and that answer is multiplied by what's on top here. All right. Why do we leave these numbers the same? Well, let's see. This is just to show you guys. 8 divided by 8 is 1. 1 times 1 is 1. Okay, that's the same thing we have here. 8 divided by 8 is 1. 1 times 4 is 4. So there's no need in trying to find a least common multiple or anything. You subtract it, leave it the same. Leave that number the same there. Subtract the 2 on the top and you're done. All right. Now, let's do away with this. All right, let's hit multiplying fractions. Let's hit that real quick. Like. All right, this will simply be 16 over 8. The denominator stays the same. Okay, the only thing that's being multiplied is the top here. All right, if it's unlike 4 8, I don't know why I love 4 8s right now. 2 5. Multiplication. All right, I'm going to take the smallest denominator. Again, those are the numbers on the bottom. The smallest one, I'm going to say, I'm trying to get to what does 8 and 5 have in common. All right, so 5 times 1 is 5. 5 times 2, 10, 15, 20, 25, 30, 35, 40. 8 has 40 in common with 5. Now, 5 times 8 is 40. Now, with 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. All right, they both have 40 in common, so that's going to be my like number, 40, 40. All right, they both have it in common. Now, how many times does 40 go into 8? Well, it goes 5 times because 8 times 5 is 40. So I'm going to divide the bottom. 8 divided by 40 is 5, and 5 times 4 is 20, and multiply the top. All right, let's do it again. 5 divided by 40 is 8. 8 times 2 is 16. Now, remember, I'm multiplying. All right, so the bottom number stays the same all the time. All right, now 16 times 2 is 32, I believe. Let me make sure. Yeah, 32. So it's going to be 320. All right, it's going to be 320. Notice this is an even number. It can be reduced. All right, it can be reduced. I'm not gonna reduce it, but it can be reduced. You're only done when it can't be reduced and it's an odd number. All right. All right. So dividing fractions. All right, dividing fractions. All right, so what happens when you're dividing fractions? What do you need to know to divide a fraction? Remember, I said this word early in the video, reciprocal. This means to flip, okay? X over Y, or 2 over 3. The reciprocal is 3 over 2. 1 over 5. The reciprocal is 5 over 1. All right? And so on. So it simply means to flip. All right? So when you guys are dividing your fractions, say you have 5 over 1 divided by 2 over 6. In order to solve this, you would need to change this sign to a multiplication sign and flip that last fraction. Get the reciprocal, means flip it. Okay, now you have a problem that looks like this. Okay, 6 over 2. All right, that's a 2, guys. Let me make it look better. 6 over 2. All right, now you need the least common multiple. Remember, we just got through multiplying, so remember it's the same concept. 1 is the least common multiple here, so I'm going to say 1 times 1 is 1. All I have to do is make it to 2, okay? All I'm trying to do is make it to 2. 1 times 2 is 2. I've made it to 2. How many times does 2 go into itself, okay? This is where I am. 2 divided by 2 is 1. 2 goes into itself 1 time. All right. Now, 1 times 6 is 6. Now, hold on, guys. 1 second, guys. Hold on. Now, how many times does 1 divide into 2 and then multiply that number by the top? All right, same thing here. Multiply that number by the top. I'm sorry about that, guys. All right, so remember to get the reciprocal. I forgot where I was. Remember to get the reciprocal, meaning to simply flip that last fraction. Change this sign into a multiplication sign. Get the lowest of the denominators. Start doing your math here. Divide the bottom, and whatever that number is, multiply it by what's on top. All right. I'm gonna speed things up just a little bit. All right. All right. What are some terms that you guys find fine when you're multiplying, dividing, adding, subtracting? What are some terms to look out for? All right, I want to cover this. All right, for addition, you will see total, okay, in all together, sum, increased by, and more than. All right, in addition. All right, in subtraction, you will see uh, difference. You will see difference, decrease, take away, deduct, and less than. All right, make sure you guys have those. All right, and for multiplication, you will see product, division. No, product. I'm sorry, y'all. Product. Now for division, you guys will see divided by per. You may even see average, divided equally. And sometimes for multiplication, you'll see something that says something like 2 times the amount. When they put a number and then they say times, they're telling you basically whatever that number is. Say it's 5, and they're saying 2 times such and such. They're telling you 5 times 2. All right, put the times 2. All right, double times. All right. I felt the need to share these because they will be in some of the word problems. All right. All right. So, all right, let's do some conversions. Yep, let's do some conversions. I know you guys, I'm not going to have you sitting still real long. All right, just want to make sure that you have the information. Okay. So I know not to be too much longer. I'm at the 30-minute mark. Okay. I understand. All right, just bear with me. All right. So we'll be converting units of length. All right. Converting units of length. All right. 1 foot is 12 inches. And I want you guys to think about this now, okay? Let's think when we're solving these problems. Yes, let's use logical reasoning, okay? 1 foot, my foot here, is about 12 inches, okay? Inches are really small, so it's a big unit, and in this big unit, I have 12 inches, all right? 1 yard is 3 feet. Or 36 inches. All right, if I have 3 feet, I have 36 inches. If I have 1 foot, I have 12 inches. Okay, so 3 of these, 1, 2, 3, 2 more of my shoes. Here's another one, and then another one. 1, 2, 3, 3 of my feet is 36 inches. Okay, or it's equivalent to 1 yard. All right. So let's talk about mile. 1 mile is 1,760 yards. Okay. Or 5,280 feet. Or 63.360 inches. Okay. 63.360 inches. Okay. So look how many miles Look how many yards make up a mile. Look how many yards make up a foot. Okay. All right. So when we're converting, when we go from foot to inches, when we go to a big quantity to a small quantity, we have to divide. And when we go from a small quantity to a big quantity, we have to multiply. For example, all right, 2 feet is equal to how many inches? All right, we already know that 1 foot is equal to 12. I'll write it on the side. Now, if I have 2 feet, which gives me 1 more foot, and it's asking me how many inches, well, we just simply multiply 12 times however many feet we have. 12 times 2, 24. 24 inches. So if we think about it, just sit back and think about it without doing any writing. I told you that one of these is 12 inches. If I put another one on top, I'm adding 1 more foot, and 12 times 2 is 24, or 12 plus 12 is 24. All right. Again, 12 times 2, 2 times 2 feet. 12 times 2, 24, or 12 plus 12 is 24. All right. So we went from a big unit to a small unit. And when we go from big to small, I'm sorry, guys. Okay. A big unit to a small unit, you have to divide. So we went to a big unit, from a big unit to a small unit. All right. So we know it's 24 feet, 12 inches in 1 foot. All right. So when we get over here, we're dealing with 2 feet. Okay. So we know off top, 24. I hope I'm not confusing anybody. All right, 2 of my feet are 24 inches because it's 12 inches in 1 foot. All right, let's do another one. Let's do another one. I don't need to erase all of it. All right, so another one. 48 inches is how many feet? 48 inches is how many feet? All right, so we're going from feet to inches. 1 foot is 12 inches. All right, if I have 2 feet, this is just without writing anything. Just thinking about it. Okay, we're going from inches to feet. We already know that 1 foot is equivalent to 12 inches. 2 feet, if I have 12 plus 12, I have 24 inches, or 12 times 2. If I have 3 feet, then I have 12 times 3 is 36 inches, or it's 12 plus 12 plus 12, okay, 36, okay, because we're dealing with feet here. That's where we started. And we started with inches, but we come into feet. All right, 4 feet, 48 inches, okay. This is what we need to know right here. All right, so that's equivalent to 4 feet. All right, let's do another one. 2 yards is how many inches? All right, first off, how many inches is 1 yard? Well, we said that 1 yard is equivalent to 36 inches. Okay, 1 yard is 36 inches. So now I have 2 of them. All right, I got 2 of them. 2 yards. So if 1 yard is 36 inches, then how much is 2? Well, I can just put 1 more yard here because I need 2 in all. And that's another 36 inches. I can either add this and say 2 yards is 72 inches. Or I can say 36 times 2, which will give 72 inches as well. Alright, what else I need to cover? Oh, doing my virtual lesson for my night class. What you need? Okay. 24 feet. Alright, 24 feet. 24 feet is how many yards? Alright, so up here, we know that 1 yard is 3 feet. 1 yard is 3 feet, okay? Now, we have 24 feet, okay? So what we need to do is divide 3 divided by 24, which will give us 8, okay? This is why. This is almost equivalent to saying, here's a yard. No, hold on. This is equivalent to this. This is 3 feet, 1 yard, okay? All right, here's 3 more, 2 yards. Here's 3 more, 3 yards. Here's 3 more, 4 yards, okay? So every 3 feet, okay, these are my feet, okay? Here's 3 feet, 3 feet, okay? 3 feet, yard number 2, 3 feet, yard number 3, 3 feet, yard number 4, and we can keep going, right? Because we have to go 24 feet in all. So this is 3, 6, 9, 12. All right, let's keep going. 12. Here's 15, 18, 21, 24. All right, 5 yards, 6 yards, 7 yards, 8 yards. All right, remember, every 3 feet is equal to 1, okay? 1. So 1, 2, 3, 4, 5, 6, 7, 8. It asked us how many yards is 24 feet equivalent to. Okay, remember these are the feet, so this is what we're going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, 3, 6, 9, 12, 15, 18, 21, 24. All right, so now that we have 24 feet here in these boxes, we stopped off on yard number 8. Okay. All right, remember, 1 yard is 3 feet. So in order for me to get to 24 feet, I have to keep going. 2 yards is 6 feet. 3 yards is 12 feet. 4 yards is 15. All right, 3, 6, 9, 12, and such till we get all the way to 24. All right. You guys practice these problems. All right, practice these problems. Email me warnerc2@mybrcc.edu. Practice these problems. Email me if you have any questions. All right, email me. I'm around the clock here. All right, so next thing that we're gonna cover, and we've covered this already as well, but let's just brush up on it. All right, metric system. Okay, the metric system. Now, the metric system, you're going to have kilo, hecto, deca. You'll have your big unit, which is meters, grams, or liters. And you'll have deci, centi, and milli. All right. Okay. So basically, all this is saying is 10 of these equals a meter. 100 of these equal a meter, and 1,000 of these equal a meter. All right. What this is saying is one of these equal 0.10 meters. All right. This is saying one of these equal 0.001 meters. And then the next one is 1 kiloliter equals 1,000 meters. All right. All right. Remember, guys, meters, grams, liters. Okay. Here are the practice problems. 5.76 kilograms to milligrams. What is that number? Well, let's look and see. We're going from kilogram to milligram. All right. So we're going here all the way over here to the milli. The kilo to the milli. All right. So our decimal point is here. All right. So we got 5.76 kilograms and milligrams, and we know because we can go 1, 2, 3, 4, 5, 6. So we take this decimal, 1, 2, 3, 4, 5, 6. We put it here. All right. All of these are zeros. Those are placeholders. All right. So that would be the answer. Okay. It would take you guys to move this comma over. I believe it was 6 times. 1, 2, 3, 4, 5, 6. All right. Put it where? Right here on the end where you stop. You count over 6 times, and then you fill the rest of the slots with placeholders, which are zeros. All right, let's do another one. All right, 7.13 meters to millimeters is where we're going. All right, meters to millimeters. All right. All right, so meters is here. So this is where we'll start. We'll go to millimeters. 1, 2, 3. All right, so we would come to this decimal, move it 1, 2, 3. So this will be a placeholder right here. Okay, 7130 point. Okay, that will put us from 7.13 meters to 7130 millimeters. All right, I know it looks a little funny, but hey, this is how you do it. All right, let's do another one. Let's do another one. 2.2764. 2764 centimeters to meters. All right. So 2764, you have a number like this, don't be confused. All it's saying is 0.000, whatever it is, all right? All right, this is just a whole number. Don't be confused by the comma, all right? It means that there's still a understood decimal place behind the last number, okay? So this is where we'll start with our decimal, even though it wasn't given to us, all right? We understand that it's here, all right? So centimeters to meters. So I'll go from centimeters back over here, which is 1, 2, all right? So I'm gonna take this decimal, I'm gonna move it twice, 1, 2. So this gives us 27.64 centimeters. I mean meters, because that's where we're going to. We're going from centimeters to meters. All right, so remember, you don't have to memorize this per se. Just know that, just remember that King Henry died unusually drinking chocolate milk. All right. So you'll know. And remember, this is meters, grams, and liters. This is unusually because it's nowhere on the chart. All right. King Henry died unusually drinking chocolate milk. Get rid of this starting to look like chicken scratch. All right. Now, we did those examples for the metric system. Trying to think if there is anything else that I need to. Oh yes, I do need to cover one last thing, and then I'm gonna let you guys go. All right. When you're dealing with decimals and you're dealing with them, say it says least to greatest. Okay. Now people get confused, and I just want to cover this. All right. This is an example. This is an example. Decimals from least to greatest. All right. Look at this. All right. So the first thing I'm going to do is make sure, well, I'm going to put these numbers closer first so you guys can see. I'm going to line them up. All right. I'm going to put all the decimals right there so I can see everything. All right. 0.4702. And then 0.86, okay? All right, so I got all those numbers. I have all the numbers here. All right, first thing that I'm gonna do, now that I have them lined up, you guys know that there are understood zeros right here, okay? Even though you may not see them, it's always understood zeros, okay? Don't let that confuse you, okay? All right, I went on and put the zeros here to show you guys how they pan out, okay? So I'm going to look at what's here behind my decimal in each number. All right. 2 of the numbers have zeros behind the decimal. Okay. So if I'm going from least to greatest, this number here has an additional 0. All right. This one has a 4. So this is less than this number. All right. So I'm going to write this number over here. All right. I'm going to get rid of this. Now the next number, being that this has a 0 just like the last number, okay, and it has, and see these two values here, they have no zeros. One has a 4, one has an 8. So 0 would be, this would be the next number because 0 is less than 4 and 8. So I'm going to write 0.0489. All right, I'm going to get rid of that. All right, so now these two numbers, see 4 is less than 8. So now I would write 0.4702, okay? And my greatest number, because of this 8, okay? This is the greatest. Okay, so we just went from least to greatest, okay? Without having something so complicated looking. All right, let me do 12, 0.22, 0.009, 0.1, 0, 0. All right, so this is another set, just a practice set. Okay, looking at all of my decimals. Okay, the first number I see next to each decimal, this is what I have to compare. Okay, 0 is the less compared to 2 and 1, and there's another one. So I'm gonna write this one first. I'm going from least to greatest. Okay. All right, nothing can compete with that 0. That's the lesser amount. All right, so I got that one out the way. My next one, I have a 1, 2 here, a 2, okay, and then I have a 1, 0. All right, I have a 1 in both of these terms, 0.1. So since I have a 0.1 in both of them, I look at the number next to, okay? I look at this number. Which one is the least amount? This one, okay? 0 is less than 2. So I will write 0.100. All right? All right, so I'm stuck with these two, okay? What's the lowest value between these two? Well, I'm going to look at this number here again. 1 is less than 2. So I'm going to say 0.12, and then the greatest would be 0.22. You always want to look at the number that's next to the decimal, okay? All right, 4, 2, 1. 3, 9, 8. Okay, 4 is greater than 3. All right, 3 is less than 4. All right, and that would, if I would say least to greatest between these two numbers, I'll say 3, 9, 8, and then next it would be 4, 2, 1. All right, so that's just another little example. All right, decimals, and that's decimals from least to greatest. What if you were thrown a fraction in here? What if you were thrown 10 over 6? Okay, you would have to turn this into a decimal. Okay, so that would mean that you would divide 10 into 6, and you'll go from there. All right. All right. And also when you're dealing with percentages, let me just cover this, and you see an amount like what we just went over, 1, and you have a decimal here and it says 25. Know that everything to the left, okay, that's the whole number, okay, that's out of 100, okay, so it would be 1 out of 100. Everything to the right of this decimal here, 25.25, is a portion, okay? That's a portion of this whole number, all right? So everything to the right of the decimal is, this is on the right, it's the portion. Everything to the left is a percentage, okay? All right, so that will wrap up today's class. I'm sorry that it was an hour. It lasted an hour, but we did get to cover pretty much everything that we needed. We got a good start off of the start that I've already given you guys. If you need any kind of assistance, or if you have any questions, please contact me. I am available. All right, you guys enjoy the rest of your evening. And again, contact me if you have questions. Bye-bye.